Okay, it looks like we do still have a few more people joining. But I think we can get started. Welcome to Bulk Data Implementation on Public Cloud with Secure Sharing of Data Files. And I will turn it over to our speaker.
Hi everyone, good morning and good evening. Welcome to DevDays community talk session. In this session, we are going to talk about bulk data implementation over public cloud with secure sharing of data files. Hope you are enjoying all your sessions so far. I am Chetan Kumar Jain, working as a senior architect for Optum Global from India office. I have 17 years of experience in IT industry, including the different areas like analytics, big data, cloud computing, and interoperability. In course of all this work experience, we come across challenges with sharing the data between one system to another. And in today's session, we are going to talk about one of that problem where when we share the bulk data, the big data files between the system. So, and that too in the interoperable way. So FHIR has suggested the bulk data access API implementation guide, which we have implemented. And on top of it, we do face some kind of challenges for securing the file exchange and making it smooth transfer from one system to another over the cloud. And there comes the challenges, and then there are some features available from the different cloud vendor which makes the uh, life easier to achieve that. So we will discuss all these and share the experience what we have gained, followed by the Q&A session. As I am doing this virtual, unfortunately I could not travel to USA for this event. This is a pre-recorded session and you can ask the question anytime during this presentation over the chat, and I would be happy to answer those. So very first, let's talk about why we really need to transfer the data in bulk. So in general, when we do the transactional or analytical systems, we work on or we exchange maximum one or few hundreds of record, but not more than that, which is very good to cover a particular patient, practitioner, or a group of members, right? But when we really need to work on a bulk data, which belongs to the entire population, then the traditional way of REST APIs, right, doesn't serve the purpose because it cannot go exhaustive to cover up the entire population. So there it needs there it is required to do something differently to share this data. That is one point. And the second point is that with the bulk data API, right, we can transfer the data in bulk, but what are those business use cases for which we need to transfer? So here we have listed few of those, like we want to run some machine learning algorithm or the AI ML algorithm, right? So you need the entire data set where you can run or train your model. For that purpose, you need to extract the data from your system. There can be scenario when you are moving from one system to another, and then you have to transfer entire data set from one to another systems. There may be scenarios when you want to run some kind of enrichment or transformation for the analytical purpose, and for that you need the entire data set. So there can be various different business reason for which you need to get hack of the entire data set. And there comes the FHIR bulk data access API implementation proposed by HL7 itself, and which very clearly specify each and every aspect of sharing this data in the bulk. I have just highlighted few things over here. The very first is the dollar export operations. That operations enable the triggering the extract event on your FHIR server, maybe for a particular resource, a group of resources, or it can be on the entire server, right? As you see, these can be the different endpoint URL accordingly. And it comes with multiple parameters. Few of those we can talk over here, like we can choose what kind of output format we are looking at. So generally the .nd JSON has been supported and suggested, where the .nd JSON is nothing but a new line delimiter JSON file, where every line represent one record, one FHIR record, right? And the $_ parameter, which tells us like for what duration of the data you're looking for, maybe for last 1 year or 2 year or last 10 years of data we want to export. And then underscore types helps us to provide a comma separated list of the resources. So what all resources I want to pull out the data from the system. There are plenty of more other specification is being defined in the IG, and we should refer that HL7 IG, which I have given the reference at the end of this presentation. So when we share this bulk file, which really grow in the size, maybe 500 MB, 1 GB or 1 terabyte size of it, there are a lot of challenges we face, like what kind of protocol do we follow? If we do in a traditional way, like a server put a file on the server, maybe a NAS server or a storage server, and then we give the access to the all consumers, they log in through the and pull the file through FTP, SFTP protocols, right? So you have to enable it for the public access within or outside of your network, and then you have to give the credential to the different consumers who can log in into your server and pull the data, and then they are bound to use the FTP or SFTP protocol to pull those files. The data file size which grow in size can really put a challenge, right? And then it has to be done all, there has to be some manual process to trigger this process, either pushing the file or extracting the file from the server. So these are the different challenges we face when we share the bulk file. So in one of our implementation, we faced all these scenarios, and then we explored like what are the different possible solutions we can go with, whether it is on-prem or the over the cloud. When we go into the cloud, there are different vendors available in the market, AWS, Azure, or GCP. All of those offers one key features, which is known as self-signed URL for storage object. So what does it mean? It means like you have one or other object stored in your storage layer in the cloud, and you want to give access to that object to someone. And for that, you create their account, give them the different access and permission to log in into your account and access the object, which pose a lot of security issues. So just to avoid that, there is a feature called self-signed URL. So what it represents is the person who has access to this storage object, they create a URL, generate a URL for that particular object, which is pre-signed or self-signed. That means it includes all the required token and the credential detail, and we share this URL with the end consumer. So whoever get access to this URL, they would be able to access these storage objects. So they would be able to read, write, or delete as per the URL permission. Another thing is that this URL come with the expiry set. So URL would be valid only for 30 minutes or 60 minutes or 1 day as per the configuration. So using this, we don't have to create a user account for each and every consumers, and we don't have to manipulate our roles and permission on our cloud account to manage that, and then we can save all our other storage object to get exposed to the end user, right? So in the AWS world, this feature is known as pre-signed URL. In Azure, we call it shared access signature. And similarly, in the Google Cloud, we call it signed URL. So using all these, we can generate a URL for a given storage object and then give that URL to our consumers. So how did we implement it this in our AWS cloud account? So we had these bulk files or our data stored in the cloud, and on top of it we enable the FHIR server, which supporting the dollar export operation. So we create those REST APIs endpoint and give the user credential to our users who represent as a FHIR client, and using those credential and token, they can invoke our API. So very first, they call the dollar export API by invoking the export operation. This is asynchronous API which goes to the FHIR server. FHIR server accept this request, acknowledge it by giving the 202 REST status back to the client, and same time it gives the job ID or the job URL which client can use further to get the status of this export event, right? So that is one thing the FHIR server does. And second thing, the backend, it trigger the bulk data file generation. So the process runs and it works on the storage layer to pull out all the data, required data, generate the NDJSON file, and save it on the cloud in one particular bucket or the store, right? So meantime, the client can keep looping on the FHIR server by calling the get status URL and keep checking whether the request is in progress or it has completed. So once it get completed, the FHIR server return the URL generated for those files which need to be transferred, and those URLs stamped with the time expiry limit is being encrypted and returned back to the client in the response of API. So the client, the FHIR client who is invoking those API, they get the response back, and in that response, they receive the URL for each and every file which is being generated based on their dollar export dollar export call, right? So for which parameter, for which resource, or for what duration. And the size can be configured at the server level, where we can say that this can be we can go maximum 500 MB file size or 1 GB file size. And accordingly, if data is more than that, it create the part files. So every part file, let's say 500 MB. So if the data is total 2 GB, then there would be 4 files, each 500 MB, and there would be 4 URL given back in the response. And then client automatically automate the process to parse the response, get that URL, and then start downloading the files in the HTTP protocol or HTTPS protocol. So that is very important thing, that entire process can be automated, the pipeline can be built, and all the manual process can be avoided. And the same time, the security be maintained. You don't have to expose anything other than the required file to the end user, and you don't have to create any user in your, or set up the roles and permission in your cloud account for each and every client. You just give the access to the API, and whoever get access to API, they will get the URL, and then whoever get the URL, only those will be able to download the data. So these are the few references I have listed down. So the bulk data access implementation guide, which talks in detail for all this implementation detail. And these are the 3 URL for these 3 major cloud vendor in the market for this feature. So that's conclude my talk on this topic. In real world, we implemented it and then successfully deliver and build a pipeline fully automatic, which started by the API call and then download the files at the client level in the HTTP protocol automatically. And then all the validation, everything can be done smoothly. So if any time for the Q&A session now. Before that, during the entire DevDays, you can find me on the Vuha app, or anytime there or after, you can email me on this email ID if you have any question, and I would be happy to answer you. Thank you. So we have time for Q&A. Please let me know if you have any questions around it.
There are two questions in the Whova chat, in the Q&A. Can you see those, or would you like me to read them?
I can't see those. Okay, I can see now. How do you protect against replay attacks when using the signed URL approach? Time expiry of 30-60 minutes may provide too large of an attack window. So it's like not everyone would get access to those URLs, right? So only the person who get access to those APIs will only get the access to the URLs, and they only can download. So if URL get exposed to the unwanted folks, definitely they can download. Does that answer your question? The next question is, this system is responsible for applying user or role-based authorization. So the only user we create on the API interface, API gateway. So that's where user get the client ID and secure token to invoke the API. But on the self-signed URL site, no need of creation of any user or any account. The person who has access or who is owning those data objects get the URL created and share it through the APIs. So the URLs are being like loaded with the credential detail, but then they are exposed through the API only. So the only one who get access to those APIs can only access those URLs. So that's the security layer on there.
Can we take a question from the room? Can y'all hear me?
Yes.
So this is sometimes can be a long-running process to accumulate all of the bulk data, and one of the parts of the polling is how much time is left. How are you all able to give any accurate time measures for how much time is left when they do the poll back? Or how are you handling, the time delay between the initial request and how long it might take to generate all that data?
Right, good question. Yeah. So in this particular implementation, what we did is like we were aware that what user is going to ask for. So we pre-extracted and get the files pre-ready. So as soon as the event get trigger, within few seconds or a minute, we could return back the response. But yes, that's the challenge when you are going to generate the data on the fly. Once the job get triggered, it's gonna take time. Yep. And it's hard to calculate. There can be various factors in generating the files, right? Are you facing that issue? Sure.
I have a question regarding how you handle errors in this process. It's a very long-running process. What do you do if you encounter some problem in writing a resource out in the ND-JSON? Do you log it in some way? Do you move on, or does the process stop? How does that work?
So as I said that we were pre-extracting the data. So all the good records are getting converted into ND-JSON, and then we are keeping a log of the bad records at our end to further diagnose and figure out like what's wrong with those and how we can fix it. but that process doesn't impact the client asking for the data. So whatever good data is available, we share the data with the user. So we don't stop the process from the consumption side. Any other question we have?
We are at time. If nobody else has any questions, we'll give you a few minutes to get to your next session.
Sure. Thanks, everyone. Thank you.
You.